we are back with the new topic, and today my topic is beta lactam. We all familiar with the beta lactam, that it is a cell wall synthesis inhibitor, and it contains many drugs, but today my drug is penicillin. We know that penicillin is a structure analog of DLA and DLA. It binds to the penicillin binding protein and it inhibits the cross linking of the peptidoglycan, and in this way it inhibits the synthesis of the cell wall of the bacteria. So we know that bacteria need cell wall, which is of the peptidoglycan, and it preventing it from the osmotic cell pressure lysis, and it is giving it rigid support. So let's took the word peptidoglycan. Means it has peptide and the glycan. Peptide, which is of the pentapeptide, in which DLA is one of them, and the glycan is NAG, N-acetylmuramic acid, and the N-acetylglycemic acid. Okay, now we have said that penicillin is inhibiting the peptidoglycan cross-linking. Let's see the structure in the diagram. We better appreciate this. Okay, now see in the diagram. So this is the name, which is of course of the glycan, and here is the neck, here's the neck, and there is again the name, there is again the name, and these are linking by the O linkage, which is of the glycosidic. Okay, and we said that there is a pentapeptide which is come over here, and here is the pentapeptide. So I said this is a peptide, and the other is the glycan, which is of glucose ring. Okay, so we have said this, that there is a cross-linking occurring in between the peptide group. So, and which is doing the cross-linking? The cross-linking is doing by the transpeptidase enzyme, and if I give our drug the penicillin will come and bind this structure, which is transpeptidase, and inhibit the transpeptidase. So in this way the cross-linking will not be there, and the cell wall will not be formed, and the cell will burst. And the cell could not bear down the pressure of osmosis, and the osmotic lysis of the bacteria will be occur. I hope this is the simplified way of the action of the penicillin. In this way our mechanism is done. So what are the uses of the penicillin? We know that penicillin is used in the Treponema pallidum, which is syphilis, and if we give this drug to this syphilis patient, we know there is a reaction which is Jarvis-Hexamer reaction occur, which we will done when we are covering the syphilis, and it is used to treat the Neisseria, and specifically it is used to treat the Streptococcus pneumonia, Streptococcus pyogenes, and it also used to treat the actinomyces. What are the adverse effects of this drug? Adverse effects are hypersensitivity reaction and the hemolytic anemia. Okay, now the bacteria is too sharp. So what the bacteria has done? The bacteria has done the mechanism to resist this drug by penicillinase enzyme, and it is plasmid mediated resistance. We will discuss the mechanism of the resistance of the bacteria, through which bacteria will become resistant to the antibiotic. Just like there are three mechanisms which are famous. One is intrinsic mediated resistance, other is chromosomal mediated resistance, and the third is plasmid mediated resistance. So there are three mechanisms through which bacteria will become resistant to the antibiotic resistance mechanism. Okay, now look further drugs of the penicillin, which are ampicillin. Okay, there are other drugs which I have named them. It is ampicillin and the amoxicillin. The good thing about this drug is the wider spectrum, but the very bad thing about this drug is penicillinase sensitive, means it is inhibited by the penicillinase. But the scientists are too clever. They have developed the chemical like clavulanic acid. The other are sulbactam and the tazobactam. So these are beta lactamase inhibitor, means the scientists have combined this chemical with the drug so that our drug will not be inhibited, and in this way our drugs will remain functional. Bacteria could not inhibit our drugs. Okay, what these drugs are doing? I have a mnemonics which is enter help. Of course, what this is? It is enterococci. H for H. pylori, and the other H for Haemophilus influenzae, and the E for the E. coli, and the L for the Listeria, and P for the Proteus, S for Salmonella, and Shigella. So it is giving a good coverage against these organisms. I know there's other drugs which are methicillin and the penicillin and the dicloxacillin. These drugs are the penicillin resistant. The good thing about this drug, these are penicillin resistant. How? Because of a bulky R group which does not allow beta lactamase to enter. But the bad thing about this drug, it has a narrow spectrum, means it is used only for the staph aureus. But MRSA is the methicillin resistant, where this drug will not be helpful. So where this MRSA come from? It comes from the chromosomal mediated resistance through the transduction. It transfers through the transduction. And the other drugs are the piperacillin and the ticarcillin. We call these drugs the anti-pseudomonal. Because it is helpful against the Pseudomonas bacteria, but it is also sensitive to the beta lactamase. We have to combine with the clavinic, sulbactam and the tazobactam. This is all about the penicillin. I know I go very fast to the drug because at least you should know about the penicillin, amoxicillin, ampicillin, and the methicillin, nafcillin, oxacillin, and the piperacillin and the ticarcillin. We just know the basic information regarding these. But if I go further about the adverse effect, then piperacillin and ticarcillin causes the hypersensitivity reaction, and the methicillin, nafcillin, oxacillin causes the interstitial nephritis, and the amoxicillin and ampicillin causes the pseudomembranous colitis, which is caused also by the clindamycin, the famous drug, and it also causes the hypersensitivity reaction. I hope this is clear. Okay, thank you. See you in the next lecture.